Hey guys, I hope that I'm live right now. Please let me know if I'm audible and there's no issues with the audio or the video, guys. Hello everyone, I hope that I'm live right now. If you guys are able to listen to me properly, as well as there's no issues with the audio or the video, please do let me know. Hello everyone, I hope that I'm live right now. If you guys are able to listen to me properly, as well as there's no issues with the audio or the video, please do let me know. Great, amazing guys, amazing. So so how was your day, guys? Please do let me know. Today we'll be starting off with numpy. Okay, so that will be our aim for today. We'll be starting off with numpy from today, guys. Okay, so we'll be finishing off with numpy as well. We'll try to finish off numpy today itself, that we are able to start off with the next topic, that is Matplotlib and Seaborn from tomorrow onwards. Okay. Okay, great. So how was your day, guys? Was everything fine today? Please let me know. Good evening, everyone. Good evening. Okay, so that's great. That's great. So, can somebody let me know what are the different things that we have studied in the past few days? Okay, what have we studied in yesterday's class, guys? Can somebody remind me? Please let me know. What are the different things that we studied in yesterday's class, guys? Please let me know. What are the different things that we studied in our yesterday's class, guys? Lists, dictionaries. Okay, great. Okay. Anything else? Tuples. That's great. Tuples as well. Okay. So can you guys write what is the mutability and the order of strings, list, tuples, and dictionaries? Okay, not dictionaries. Let's say for string, list, and tuples, what is the mutability and order, guys? For string, lists, and tuples, what is the mutability and order, guys? Can somebody let me know? For strings, lists, and tuples, what is the mutability and order, guys? String is immutable. Okay, great. What about lists and what about lists, guys? Lists and tuples. What about that? Okay, great. So everybody is writing the exact correct answers that we were expecting. Amazing, guys. Amazing. So, like I said, in today's class, we'll be starting off with NumPy, as you're able to see. This is all that we are going to cover in our NumPy's class today. And we'll try our best to complete NumPy today itself. I don't want it to extend to tomorrow's class. Tomorrow, we'll also be discussing about the roadmap to become a data analyst, a data engineer, data scientist, or a software engineer as well. So that is what we'll be doing tomorrow. So we'll be starting off in Matplotlib and Seaborn tomorrow onwards, and we'll also be discussing about the roadmap that you guys have to follow for learning as well. Okay, so don't worry about it. Today we'll try to finish off with NumPy. Okay, we'll start NumPy and finish it off as well. So should we start off with our today's class, guys? Please let me know. Should we start off with our today's class, guys? Please let me know. We start off with our today's class, guys. Please let me know. Okay, great. So let's get started, guys. I'm providing you guys with the link for this Google Colab. The link for this particular notebook is in the pinned section right over there. Okay, I pinned up the link, guys. opening it, I just deleted it. Okay. Okay, so I pinned up the message, the link for the notes of NumPy in the live chat, so you can definitely join the notebook from right over there itself. Okay, and I'm reducing the slow mode to 30 seconds so that you guys are also able to enjoy the class. Okay, okay, so let's get started, guys. Let me just open up the live chat on my phone. I made a mistake. Instead of making it as the most fastest live chat possible, I was not able to do that. So the live chat is a bit slow and it's on normal mode itself. Okay, so try to be as prompt as possible, guys. It might take a minute or two to register your answers. Okay, so please try to be a bit prompt today. Okay, okay, so let's get started right away with the class. So NumPy, in machine learning, data science, and generally dealing with data in general, numerical data, you'll be dealing with this data in the format of Excel sheets. So you have already seen Excel sheets in your daily life, and these Excel sheets can be represented as a matrix. Okay, these Excel sheets that you have, I need paint. These Excel sheets that you see in your daily life, these look something like this. Okay, these look something like this, and they have rows and columns, and this is very similar to matrices that you have studied in your mathematics in your 10th and 11th standard. So these are very similar looking to matrices, and these type of computations that you have to do, any type of scientific computations, that you have to do inside of Python, you do it using a library called as NumPy. And usually NumPy is used for matrices. Okay, matrix multiplications, matrix algebra, that is where NumPy is used. Now you will be asking, sir, what is library? Okay, what is the package? What is a library? Let's try to understand that first of all. Okay, so what happens is you want to do something. Okay, you want to take up a particular, let's say, name. Okay, you want to take up a name from the user. Okay, you are having a user right over here. You want to take a name from the user. You want to then showcase a message, hello, name of the user, how are you, something like that. Okay, so this is what you want to do. So instead of writing this entire thing, okay, taking in the input from the user, then doing something with that, you can directly use a package for this that has already been built by someone else. Okay, someone else has already write all this code for you. So for example, this takes like 100 lines of code. Okay, let's just assume that this takes 100 lines of code to do this. Taking an input from the user, creating the taking that name, saving it somewhere, making messages, all these kind of stuff. So instead of writing all that code yourself, somebody's already written this 100 lines of code and provided to you a package, or provided to you a box, a black box, where you can just give the input, that is, okay, you want to give the name, and directly get the output, that is like a greeting message at the very end of the thing. Okay, so that is called as a package. So NumPy as well is a package. NumPy as well is a package. It's a scientific computation package in Python. Okay, NumPy. Now, when you're learning NumPy right over here, what happens in the background is it has written a lot of optimization. So, for example, if you're normally doing any kind of computation using just Python, if you're doing any kind of computation using just Python, what would you do? Okay, you would just use Python to do that. It will take you a lot of time. Okay, it will take you a lot of time at the very end of the day. What NumPy has done, that all that Python code that you were writing, they went through various research papers, they went through various optimizations, algorithms, and they used all that algorithms and optimizations to write a very optimized code, a very like time and space optimized code right over there, and they saved it inside the package of NumPy. Now whenever you are using NumPy at the very end of the day, you will be able to, like, your code will be much more faster than what you were originally writing just using Python. Let's try to see that. Okay, let's try to see that in a very practical sense right over here. Let's go back to our code. So numpy stands for numerical Python. The full form for numpy is numerical Python. It is a fundamental Python for scientific computing in Python. Okay, it's a fundamental package for scientific computing in Python. Numpy provides Python with an extensive math library for capable of performing numerical computations very effectively and efficiently. These lessons are intended to be a basic overview of NumPy and introduces some of the most important features. Okay, so let us look at why do we need to use NumPy. We could have done everything using just Python, and inside of NumPy as well, just Python code is written. Why do we want to use NumPy at the end of the day? Okay, you might be wondering why people use NumPy. After all, Python can handle lists, and we have seen in the intro to Python lessons. Okay, even though Python lists are great on their own, NumPy has a number of key features that give it a great advantage over Python lists. One such of the features is speed. While performing operations on large arrays, NumPy can perform the operations several magnitude faster than Python lists. Let us look at how fast NumPy actually is. Let's look at the code to understand how fast NumPy is. Now the next few lines of code you don't need to understand. Please try to understand that this is just to make sure that you are able to understand that NumPy is very fast when compared to Python lists. You don't need to understand these lines of code. Okay, whatever I'm saying, you just need to understand that much. You don't need to understand these lines of code, guys. Okay, so I will just give you a very high level overview of this. Again, I'm explaining you don't need to understand these lines of code. It's just meant to be an example to prove how fast NumPy is when compared to just Python. Okay, so right over here we are importing some packages like time and numpy. Okay, we usually import numpy as np. That is, we are, instead of using numpy, so wherever you want to use the package, we'll have to write numpy again and again and again. So you don't want to write that entire like huge piece of word again and again. So to enhance that, we are assigning it a nickname. Okay, we are assigning it a nickname, that import numpy as np. Okay, your import numpy as np, so we are assigning it a nickname right over here. Now we can access numpy by using the word np itself. So let's run this particular line of code, guys. Let's click on run anyway right over here. It will take a second or two to run this particular line of code, guys. Give it a second. Give it a second, guys. That's being connected. Now it is importing time and importing numpy as np right over here. Okay, once it is imported numpy, what we are currently doing is we are creating an array. We are creating an array of 1000. We are creating an array of 1 billion elements. Okay, we are creating a list of 1 billion elements, guys. Okay, this code is basically used to create a list of 1 billion elements, guys. Okay, 1 billion elements are there in this particular list. Okay, there are 1 billion elements in this particular list, guys. Now you need to understand that we don't need to understand this code, how this code functions or not. I'm just giving you an overview of this, that we are creating 1 billion elements in this list. Now what we are doing right over here is we've written a code that basically clocks how much time it takes to run this particular line of code. Whatever I have written in the middle, how much time does it take to run this particular line of code? So right over here, I'm calculating the mean of all the elements present in this list. I'm calculating the mean of all the elements present in this list, guys. I'm trying to calculate the mean of all the elements present in this particular list. Okay, so to do that, I'm using sum of x. We have already learned about how to calculate mean. Okay, you calculate mean by the sum of all the elements present in the list divided by the number of elements present in the list. So we already know how to calculate the sum of all the elements present in the list. We have this sum. We have already looked at it yesterday, guys, how to calculate the sum of all the elements present in the list. You use the sum function. So sum method right over here. So we are using sum of x, that is all the elements present in x, divided by the length of x, that will give us the mean of so we are basically clocking how much time does it takes to execute this particular line of code, how much time it takes to calculate the mean of all the elements present in 1 billion elements present in that list. Okay, using just Python. So this is just normal Python code, guys. So I'm running this. Let us see how much. Okay, so we need to declare this, and then we will be running this line as well. So we are creating 1 billion element list right over there. Okay, so it is taking some time to create that. Okay, because it's 1 billion elements, so it's taking a minute or two. And then we are calculating, okay, we are calculating it, how much time in seconds it takes to calculate the mean of those 1 billion elements using just normal Python, guys, just normal Python. So as you're able to see, it's still running, the code is still running, so you are able to see how much time it is taking, guys. If the code is still running, okay, you're able to see how much time this is actually taking us. So give it a minute or two. Okay, it will take 1 or 2 minutes to actually calculate the average from the list itself. Okay. Guys, this is the fourth day today. Still, people are writing present, sir. Like, some of the people are really very dumb. Like, how can I explain it? Okay. Like I told you guys, you don't need to understand how this code functions. This is just to show you guys how fast numpy is when considered when comparison to normal Python. Okay. Please do not write present sir in the live chat, guys. Please do not write present sir in the live chat. Okay. Focus upon the class itself. Do not waste other people's and your time as well. Okay. Please focus upon the class. So why has the RAM increased? That is also a good question. Okay, it has taken up almost 8.28 GB of RAM out of our 12.68 GB that has been allotted to us. Why is that the case? Because this entire 1 billion parameter, 1 billion element list that you have created lives in the RAM itself, and it is actually taking up almost 6 GBs of your RAM. Okay, this is actually taking up almost 6 GBs of your RAM itself. That is why your RAM has been taken up right over here. Okay, the next thing that you're able to see is it took us 86 seconds. It took us 86 seconds right over here to calculate the mean. Okay, it took us 86 seconds to calculate the mean using just Python. Now we are going to use numpy to do the same thing. Okay, to do that, we are having np.mean. Okay, this is the function that we have to use to calculate the mean of the array, okay, of the element. As you're able to see, np.max, numpy.max. Np is the shorthand notation for numpy, and that we are calculating the mean right over here. If I'm running this particular line of code, you're able to see that it is taking less than a second. It took us 0.688 seconds. Okay, it has 0.688 seconds to actually do that. Okay, just 0.688 seconds. So it took us 86 seconds to do that using just Python, and less than a second doing that using numpy. So that is the speed that numpy operates on. It's doing the exact same thing. It is also calculating the mean, but it is doing that in just 0.68 seconds. That is the beauty of numpy. That is why we need to learn numpy and we need to use numpy, because it's easy to use. You don't even need to know the formula. You don't even need to know the formula for how to calculate mean. You just do np.mean right over here. It handles the formula for you, and it does that in just 0.68 seconds. Okay. So now let us look at numpy. So now we'll be trying to understand the code and everything. Now we'll be learning numpy right now. Again, like I said, the above code that you were able to see, you don't need to understand the code. That was just an example to make sure that you are able to understand why to use numpy. Now we'll be understanding the code as well. Okay. So creating numpy ND arrays. At the core of NumPy is a concept called as ND arrays. They look very similar to NumPy Python lists as well, where ND stands for n-dimensional arrays. Okay, n-dimensional arrays will be a one-dimensional arrays, a two-dimensional arrays, a three-dimensional arrays, and so on and so forth. So what do I mean by arrays? I think so arrays is a particular concept that most of you would be very familiar with. Okay, so you're having a one-dimensional array like this. Okay, so this is how your 1D array or one-dimensional array would look like. 1D array. Then you are having a two-dimensional array like this. Okay, this is something that will be a 2D array or two-dimensional array. Okay, then you can have your three-dimensional arrays as well. So it would look something like this. So this will be your 3-dimensional array. Okay, so yeah, that will be a 3D array, and so on and so forth. Of course, you cannot draw a 4-dimensional array or 5-dimensional array. You can draw that, but you can go up till like 50, 60, 100 dimensions as well. Okay, so that is why it is called as ND array or nth dimensional array. Okay, or nth dimensional array, guys. Okay. Okay, so in other words, ND is a ND array is a grid that can take on as many shapes and can hold either numbers or strings inside of it. In many machine learning problems, you will often find yourself using ND arrays, and that is the reason why we are actually learning this. Okay, um, if you, for instance, you might use ND arrays to hold the pixel values of an image that will be fed to a neural networks for image classification. So just an example of where you will be using an ND array. You can use a 2-dimensional ND array or a 3-dimensional ND array to store an image inside of it. You can use a 4-dimensional ND array to store a video inside of it. Now, how to do that? Of course, I won't be going into a lot of depth in that, but this is just an example. Okay, so when you are actually doing machine learning, deep learning, and all those kind of stuff, your AI based solutions that you're creating, you're actually storing images in 2-dimensional and 3-dimensional ND arrays. You are storing videos in 4-dimensional ND arrays, and so on and so forth. So of course, I'm not going into a depth on how to do that, but yes, you can easily understand why NumPy is so important. Okay. Okay, so there are several ways on creating an ND array in NumPy. There are two things that we will be seeing right now: using regular Python lists, okay, converting a Python list to an ND array, and using an inbuilt NumPy functions. These are the two methods in which we can convert or create an ND array. Okay, we will be first looking at the first method, that is using normal regular Python lists. Okay, we will be using the normal regular Python lists right now to be able to do that. So right over here, first of all, whenever you want to use NumPy, you will start off with first importing NumPy, because you need to import it so that you are able to use it. Okay, you need to import it so that you are able to use it right over here. So import NumPy as NP, like we have already discussed. Now to convert, so this is a list. Okay, this is a Python list right over here. 1 2 3 4 5. Again, a simple Python list. You want to convert it to an NP array. Okay, you want to convert it into an ND array. You just have to write numpy.array, and then in the parentheses the list that you want to convert into array itself. Okay, the list we want to convert it into an array itself. Yeah, are you guys able to see this? Please let me know. Are you guys able to see this? Please let me know, guys. Are you guys able to understand this? So we are basically converting a normal list using np.array to a ND array. So right now what we are getting as an output, this is our ND array. Okay, this looks exactly like a list, but this is our ND array. Okay, Arpit, I have already told you guys that the video will be posted by tonight. Okay, not right now because this is a bootcamp that is going on. So after this bootcamp has ended, after 1 hour, we'll be posting the Hotstar video. Okay, so this is how you are able to convert your list to an array. Okay, now another important property of an array is its shape. The shape of an array is the size along each of its dimensions. As you're able to see, NumPy ND arrays have attributes that allow us to use information about them in a very intuitive manner. For example, right over here we are having a 1-dimensional array. Okay, we are having a 1-dimensional array right over here that we are creating. Okay, we can use x.shape to give us the shape of that particular array. So it has 5 elements and it is 1 dimension itself. Okay, it is 1-dimensional and has 5 elements inside of it. So x.shape gives us the shape of the ND array. Okay, you are having type of x. Okay, type of x basically gives you, so we have already learned about types in Python. We have already learned about types in Python itself. So type of x basically gives us the type of the array, that is class in numpy.nd array, that is the type of x. Okay, and x.d type basically gives the data type of the objects present inside the ND array. Now for NumPy, the data types are are a bit different. Okay, for NumPy, the data types are a bit different from normal Python. In normal Python, you are having integer, floats, strings. Okay, in NumPy, you are having scientific data types itself. So it will be very specific. So int 64, int 128, int 256. Okay, float 256. All these are different bite-sized data types that are existing in NumPy. You don't need to understand that. You don't need to understand that right now. What you need to understand is in NumPy, the data types are a bit different. You can go on and explore about it. We have already provided you with a link right over here where you can go and explore about the different data types in NumPy. Okay, if you're clicking on this particular link, it will take you to that particular page. Go through the entire page, try to understand as much as possible, guys. Okay, but that won't be covered in this particular program. Okay, so you can use these particular methods, that is shape, type and data type, on your NumPy array to get more information about the array itself. Okay, to get more information about the array itself. Let us run this right over here. You are able to see that the dimension of this particular ND array is having 5 elements and 1 row. Okay, X is an object of class numpy.nd array. Elements of X are of type int 64, that is integer 64-bit. Of course, you will have to go to this particular link and try to understand what this 64-bit means. Okay, so you can even create a particular ND array which has just particular strings itself. And create an ND array, so having a string, having a list of ND arrays right over here, you can just create that as well. Okay, so as you are able to run this particular line of code, you will be able to see that the data type is U5, that is Unicode 5 itself. Okay, so strings as well right over here has different type of data types in NumPy. So please go and explore that. This is called as Unicode 5. Okay, so you can create a array of just strings as well. Now you need to remember that unlike lists, in lists you can have the same array, you can have the same list of different data types. But in NumPy ND arrays, you can have an array of the same data type itself. You cannot have multiple data types in the same array. Please try to remember this, guys. You cannot have multiple data types in the same array inside of ND arrays. But inside of list, you could have multiple data types inside of a same list itself. Okay, please try to remember this. So what happens if we are trying to put multiple data types inside of it? We're trying to put multiple data types inside of it. We are having a multiple data type list right over here, 1, 2 and volt. Okay, 1, 2 and volt right over here. So if I'm running this little line of code, if I'm trying to convert it into a ND array, you are able to see that all the elements, even the integers, got changed to strings. Even the integers got changed to strings. Now what will happen is whatever is the most prominent okay, so Nikunj Kumar has asked, sir, why is it 5 comma nothing instead of 5 comma 1? Okay, very easy to understand that. If I'm just writing 5, so the shape I'm writing it as 5 comma nothing. Okay, so what we are able to understand, 5 of what? Okay, it needs to have something at the end of the day. Okay, so instead of writing, so if I'm writing 5 comma 1, what it says is like it has 1 row and 5 columns. Okay, that's it. Now I can just omit that. I don't have to write that one because that is automatically understood right over there. That if I'm writing 5, that means 5 columns and it will have 1 row at the end of the day. That is automatically understood. Okay. Similarly, when you are creating, when we are creating a particular list, so we are having 1, 2 and a particular string right over here is. So instead of converting everything to an integer, we convert everything to a string itself when we convert it to a array. Okay, why is that the case? Okay, because what would you write in place of s? What particular integer would you write in place of s? You don't know. If it was SHA, what would be the integer that you will write in place of that SHA? You don't know that. But we know that if there is any integer, we can write it as a string like this. That is the reason why the precedence of string is the highest. Okay, so the first you are having strings, then you are having floats, then you are having integers. Okay, that is the precedence of the elements. Okay, that is the precedence. So if you are having strings, floats and integers in the same list and you're converting into an ND array, everything will get converted to the highest precedence, that is string. If you are having float and integer in the same array, it will be converted to float. If you are just having an integer, then it will remain as an integer itself. Okay, are you guys able to understand that? Please let me know. you guys able to understand that? Please let me know, guys. Please let me know, guys. So this precedence is something that you will be moving further as well. Okay, this precedence will be something that you will be moving further with as well. So right over here, you can have like an float as well. So 0.1. I'm running this particular line of code, you'll be seeing that everything gets converted to a string right over here as well. If I'm removing the string, okay, if I'm having just an integer and a float right over here, everything gets converted to a float. Okay, so everything gets converted. So 1 point nothing and 2 point nothing right over here. So yeah, everything is getting converted to float. Okay, so that is something that you need to remember, guys. Okay, so that precedence is something that you need to remember. Okay, the next thing that we are having is how to create a two-dimensional ND array. So we have learned about how to create a one-dimensional ND array, guys. How to create a two-dimensional ND array. Now, what is a two-dimensional ND array? Let's try to understand that. A two-dimensional ND array is having like rows as well as columns. Okay, it has rows as well as columns right over here. Now just think about it. Okay, just think about it. If I'm having this 3 by 3 array, 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay, if I'm having this 3 by 3 array right over here, can I represent this as something as a list? As a list of 1, 2, 3, comma, 4, 5, 6, comma, 7, 8, 9. Can I represent my two-dimensional ND array as a list where each of the elements are one-dimensional ND arrays, guys? Are you able to understand this? Okay? Are you able to understand? If I'm having a two-dimensional ND array, can I represent it as a list? Okay, as a list right over here where each of the elements are one-dimensional ND arrays? Are you able to see this? Please let me know. Able to see this? Please let me know, guys. I'm able to represent it like that. That means I can even write this as a list. Okay, where the first list is of 1, 2, 3. That is a one-dimensional ND array. Okay, then we are having the second list as 4, 5, 6. And the third one as 7, 8, 9. And this is how you are able to create a two-dimensional ND array, guys. And this is the code to create a two-dimensional ND array, guys. This is the exact code to create two-dimensional ND arrays, guys. Those who have not understood this, please rewind the video once again and listen to me very carefully. You will be able to understand it, okay? So if I'm missing it out or you were not able to listen to it, just rewind it and listen to me once again. You will be able to understand it, okay? So right over here, as you're able to see, we have done just that. We are having a huge list. And inside of that list, every single element is an individual list itself. Every single element inside this list is an individual list. And this is how you are able to create a two-dimensional list itself. If I'm running this particular line of code, you're able to see that we have created Y as 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Okay, Y has the dimensions. So the shape, I'm using shape right over here. It gives me a dimension of 4 rows and 3 columns. So it gives you the dimension. Shape will give you the number of rows, comma, the number of columns. Okay, the number of rows, comma, the number of columns. So it gives you 4 rows and 3 columns. Okay. Then it has Y has a total number of 12 elements. We're using Y dot size. Okay, we're using Y dot size right over here. Then you will be using that will give you the number of elements, the total number of elements present in the two-dimensional array. It will give you the total number of elements present in the two-dimensional array. That is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. There are 12 elements present inside the two-dimensional array. That is by using Y dot size right over here. Then type of Y will give you numpy dot nd array as its answer, and type the Y dot d type, that is j type, will give you integer, that is int 64 as your answer right over here. Okay, and that is the entire process on creating a two-dimensional ND array, guys. This is the entire process on creating a two-dimensional ND array, guys. Garvit, please focus upon what I'm teaching. I've already told you guys how to create a two-dimensional ND array. If you are not paying attention, please focus upon the class because we have a lot to cover. I won't be able to repeat myself again and again. Okay? Okay, great. So right over here, as you're able to see, we are having an rank 1 ND array that contains just integer, a rank 1 ND array that just contains floats, a rank 1 ND array that just contains integers and floats. So we already know that this will all be converted to floats itself because of the precedence. Okay, this will automatically convert it into float itself because we know about the precedence itself. If I'm running this particular line of code, it will be int float 64 right over here. So all this data type, like I've already told you guys, just go to this particular link right over here. We have provided this link in the notes. Okay, go there and go through the entire stuff. You will be able to understand about the int 64 and float 64, Unicode, all these type of stuff. Okay, don't worry about it. Okay, so now that you have created a array of float, okay, you have created an array of float right over here. You want it to be converted to integer. Okay, right over here you have everything as float. You want to explicitly tell Python, explicitly tell numpy to convert this array of floats to an integer. For that, while creating the array itself, you can just write another parameter called as dtype is equals to np dot int 64. You want to specify right over there that you want to convert everything from float to an integer. So this is what you are specifying right over there while creating. So this is an array of floats itself. This is an array of floats right over here. You want to convert it into an integer, an array of integer. You just have to specify while creating the array data type, that is dtype is equals to np.int64. So it will convert all your elements. Okay, it will convert all your elements to integer, as you are able to see. It will convert all your elements to integer, as you are able to see. Rank 1 means, guys, rank 1 is something that you have already learned in 10th standard mathematics. If you don't know, then please revise on your 10th standard mathematics concepts, guys. Rank is a particular concept that is of 10th standard mathematics, guys. I hope that you guys are very familiar with this. Okay, this isn't something that is related to programming. This is basic 10th standard mathematics that we are currently doing right over here. Okay. Are you guys able to understand? Are you guys able to understand up till here? Please let me know, guys. Are you guys able to understand up till here? Please let me know, guys. Guys able to understand this? Please let me know, guys. Great, amazing, guys, amazing. Okay, so let's move on to the next particular topic, guys. np.reshape. Okay, np.reshape. We can use this function to create rank 2 ND arrays of any shape by combining them with. So basically what we want to do is, up till now we were creating arrays. Okay, we were creating rank 2 arrays or rank 2 arrays at the end of the day using just your lists. Okay, you were creating it in a list and then converting it to an ND array itself. Now you will be using the np.reshape property to directly create a particular ND array without using any type of list. Okay, so what we want to do is, it's very simple. Please focus upon this, guys. Okay, so first of all, the first line of code is np dot arrange. Okay, here you are having only one R. Please keep that in mind. Okay, so ARANGE. Okay, and then 20. Okay, 20. Let's assume that we are putting 20 right over here. So this will create a one-dimensional ND array. A one-dimensional ND array having 20 elements. Okay, it will create a one-dimensional ND array having 20 elements. That is, you start counting from 0, 1, 2, 3, 4, dot, 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 19, 18, 17, 16, 15, 14. As you're able to see, these are 20 elements right over here. Okay, 20 elements. So whatever you are putting up, whatever number that you're putting up right over here, it will create a one-dimensional ND array, a 1D array of that many elements for you. It will create a one-dimensional array of that many numbers for you. Are you able to understand this? Please let me know. np.arrange. Are you able to understand this? Please let me know, guys. You guys able to understand this? Please let me know. Great. Okay. Now on top of it, I want to convert this into a two-dimensional array having 4 rows. Okay, having 4 rows and 5 columns. Okay, I want to have 4 rows and 5 columns right over there. Okay, so 4 by 5. Now 4 by 5 ND array, a 4 by 5 ND array also has 20 elements. Okay, a 4 by 5 ND array also has 20 elements. So I can convert this 1D array using np.reshape. Okay, I can use np.reshape to convert this 1D array to a two-dimensional array having 4 by 5 as its number of rows and columns. You need to keep in mind that reshape would only work if the number of elements, okay, remained unchanged. Even after reshaping the original array, the number of elements remain unchanged. So if it was originally 20 elements in the one dimension array, it should be 20 elements in the two dimensional array itself. It can be 2 into 10, it can be 4 into 5, it can be 20 into 1. It's totally up to you, but the number of elements should always be the same between them. So let us look at this from the coding perspective. So we are creating an ND array called as X. Okay, writing np.arrange 20. Okay, so that will create a one-dimensional array of 20 elements for us. Okay, then we are having your X is equals to np.reshape. We want to reshape X, that is our one-dimensional array, into a 4 by 5 array where the row and then the column. Always remember, in your childhood you used to play with RC cars, okay, remote control cars. So whenever you are writing this, it's always RC, or first of all row and then column, first row and then column. Okay, so right over here we are having np.reshape X. Want to reshape it into 4 comma 5. Okay, so now let's run this and let's look at it. So this is our original array, as you're able to see, 0 to 19, that is 20 elements, and we are reshaped it using np.reshape X, that is the one-dimensional array that I want to reshape, and then the dimensions I want it to be reshaped into. So I'm getting 4 rows and 5 columns, and that's the exact same elements that we were having: 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19. The dimensions is 4 comma 5. The class is numpy.nd array, and then you're having your int64 as the data type right over here. That is how you are able to use your reshape to create two-dimensional ND arrays. Are you able to understand this? Please let me know, guys. I had some coffee made for me for today. Somebody drank that. Now I'm like, dude, I'm so tired right now. Okay, somebody drank my coffee today, and I'm like, if I get to know who drank that, he has to see death. Like in that One Punch Man series, whenever One Punch Man basically like punches someone, and then like the symbol for death just comes right over there. Like a dude, he is going to die today. Okay, so I'm like in my detective mode right now, trying to analyze stuff. So who might have drank it? Okay, okay. Great. So let's move on from right over here. So now instead of writing this in two separate lines, okay, instead of doing this in two separate lines, first creating a one-dimensional array, then moving on to create the reshape of that array, we can do that in a single line of code as well. We can do that in a single line of code as well. To be able to do that, let's see. Okay, we are having np.arrange. Okay, first of all, we are creating the np.range, and then directly dot reshape 4 comma 5. Okay, so instead of writing it two times, we can directly do it in a single line of code as well. We can directly do that in a single line of code as well. So np.rearrange will create np.arrange will create the one-dimensional array for us, and directly dot reshape 4 comma 5 will create the two-dimensional array for us as well. If I'm running this particular line of code, you are able to see that we have directly created the two-dimensional array. We don't have to create anything else. We've directly created the two-dimensional array without writing 2 lines of code. Just by 1 line of code we are able to do. So the first part is basically creating the one-dimensional array, and the second part is basically using the reshape right over there. Okay, so as simple as that. Okay, as simple as that, guys. Are you able to understand this? Please let me know. Amazing, guys, amazing. So this is as simple as that, nothing too different in that. Okay, Okay, now we need to understand how to get access to elements inside our np.array. Okay, inside our numpy arrays, how to get access to those elements. Okay, right over here, if you are having a one-dimensional array, it is the exact same as basically taking up the access from a list. Okay, how you were able to take access from a list is the exact same thing. We are not changing it a lot. So you can directly like s0, x1, x4 to get the access from the list. Okay, you can even take up the access of the negative indexes in the same way. It is the exact same as a normal list. It's the exact same as a normal list. So if you're having 1 2 3 4 5, first element, second element, fifth element, you are able to access 1 2 5, and first element using negative indexes, you'll be able to access that as well. So this is the exact same as lists, so nothing to discuss about right over here. But what about two-dimensional lists, guys? Shit, where is the two-dimensional list? Okay, so again, before moving on to two-dimensional list, let's try to modify the one-dimensional array. So that is also very simple, guys. And just like the normal list, how you modify the list, you can modify an nd array. So an nd array is mutable. Okay, an nd array is mutable and ordered. Please remember, guys, nd arrays are also mutable and ordered. Okay, nd elements are mutable and ordered. Okay, right over here, as you're able to see, you can directly write x. The third element, I want to change it to 20. So you are able to get, okay, instead of 1 2 3 4 5, you are able to get 1 2 3 20 and 5. Okay, so you are able to do the normal like modification that you have learned inside of your lists on your nd arrays as well. That's why it says mutable and ordered. Okay, so that is the exact same as a particular list. The next thing that you want to do is you want to learn about what about a two-dimensional list. How we'll be able to identify a two-dimensional list right over there. For getting access to an element in a two-dimensional list, you need to know the row and the column number. Okay, so for example, this is your list right over here, the two-dimensional nd array. Okay, I want to get access to this particular element. Okay, I want to get access to this particular element, guys. So what is the row number? Okay, what is the row number for this particular element? Can somebody let me know? What is the row number? What is the row index of the row for this particular element? Can somebody let me know? Can somebody let me know what will be the index for the row of this particular element, guys, inside this two-dimensional array? What is your salary at DevTown? So again, DevTown is a like a free thing. Okay, like we try to make sure that it is. Last month I got 50 rupees. To be a matter of fact, I got 50 rupees, and we went out and bought some chips and then like drank some coffee and then came back. I had to pay 50 rupees from my own pocket as well for the coffee. But yeah. Okay, so as this is index, guys, so if this is the first row, so that this index will be 0, the index would be 1, the index would be 2. So the index of the row of this particular element is 1. Similarly, the index of the column would be 0, 1 and 2. So you are getting the index of the column as 1 as well. So you will be able to get access to this element by using x 1 comma 1. That is how you are able to get the access to that particular element. What about if I want to get access to this element? Okay, if I want to get access to this particular element, guys, what would be the number that I will have to put right over here to get access to this element, the red one? Can somebody let me know? What will be the number that I will have to put right over here to get access to this element? Can somebody let me know that? Can somebody let me know what will I have to do to get access to this particular element, guys? That's absolutely clever, guys. Whoever is writing, the row number is 2 and the column number is 1. So the number would be x of 2 comma 1 right over here. X of 2 comma 1 right over here. This is how you will be able to get access to this particular element. Okay, this is how you will be able to get access to this element. This is how you will be able to get access to this particular element. You are going to use your row and your column number. Going to use your row and your column number, and always keep in mind RC. Okay, first row and then column. Okay, first row and then column. Okay, are you guys able to understand this? Please let me know, guys. Guys able to understand this? Please let me know, guys. Are you guys able to understand this? Please let me know. Great, man. Amazing, amazing, amazing. Let's move on from right over here. As you're able to see, this is our rank 3 by 3. Okay, we are creating this 3 by 3 matrix. Okay, this is a 3 by 3 matrix right over here. So I can get access to the first element by 0 comma 0. So that will be 0th row and 0th column. Then I can get the access to the second element by 0th row and first column. Okay, and then I can get the access to the last element, that is the second row and second column, so that is 9. Okay, that is how I am able to get access to elements in a two-dimensional array, guys. This is how I am able to get access of an element in a two-dimensional array, guys. Okay, now you can even modify the two-dimensional array in the same way. Whatever element that you want to modify, you want to select that and just assign the new value to that. So here I'm assigning 20 to the first element. I'm running this particular line of code. As you're able to see, the first element got modified to 20. The first element got modified from 1 to 20 right over here. So you can just write x 0 comma 0 is equals to 20 and that will modify it for you. Able to understand up till here, guys? Please let me know. Are you guys able to understand up till here? Please let me know, guys. Great. Amazing. Amazing, man. Amazing. Okay, so let's continue from right over here, guys. Now adding and deleting elements from an ND array. Okay, we want to add and delete elements from an ND array right now. We are creating a one-dimensional ND array called as X, and we are creating a two-dimensional ND array called as Y. Okay, so right now what we want to do is we want to delete the first and the last element from X. We want to delete, for example, right over here. Try to understand this. You're having a one-dimensional ND array. Okay, you're having a one-dimensional ND array called as X. This is like 1, 2, 3, 4, 5, 6, 7. Okay, the indexes would be 0, 1, 2, 3, 4, 5, 6. That will be the index. I want to delete the first element and the last element. So the code that I will be writing would be np dot. Okay, the code that I will be writing would be np dot delete. I want to delete it from the X element. Okay, that is from the X array, and the list of all the elements that I want to delete. List of all the elements. So I want to delete the element present at the 0th position. I want to delete the element present at the 6th position. That will be a list of all the indices. List of all the indices that I want to delete. Okay, this is the list of all the indices that I want to delete right over here, and then close it. Again, you don't need a semicolon at the end of Python. Okay, so right over here, as you're able to see, we are able to use np.delete, and the answer now X will become X. After running this particular line of code, X will become 2, 3, 4, 5, and 6. Okay, X will become this 2, 3, 4, and 5, and 6. The 0th and the 6th element will just be removed from the array itself. Will just be removed. Both the positions will just be removed from the array itself. That is how you are able to use delete any element from the ND array. Okay, any element that you want, any number of element that you want, you can delete it from the ND array. Okay. Similar to that, when you want to delete, okay, so right over here, if I'm running this line of code, as you're able to see, our original X was 1, 2, 3, 4, 5. Our original X was 1, 2, 3, 4, 5, and our modified X, that is, we are removing the first and the last element, and our modified X is just 2, 3, and 4. Our modified X is just 2, 3, and 4. Similarly, right over here, we are having Y as our two-dimensional array. We are having Y as our two-dimensional array. We want to delete the first row of Y. Okay, so right over here, let's try to understand this. We are having a three-dimensional array right over here. Now you need to understand that in a two-dimensional array, you can never delete a particular element. You cannot delete a particular element, because how will this look? This is not a matrix. This is now how matrix looks like. You guys have already learned about matrices in your 10th standard. Okay, this is not the shape of a matrix. The matrix needs to be either square or rectangular in shape. This won't work. Okay, you cannot delete individual elements from a matrix. You can never delete an individual element from a matrix itself. What you can do is you can delete either an entire row or an entire column. You can delete an entire row or an entire column so that you are able to preserve the rectangular shape of the entire thing. Okay, the rectangular shape of the entire matrix, you are able to preserve that. For that, we need to delete an entire row or an entire column. Okay, now how to do that? Okay, so if you want to delete a row, so the code will be, so for example, this is y. Okay, this is y right over here. We are having 1 2 3 4 5 6 7 8 9 right over here. We're having 1 2 3 4 5 6 7 8 9. Now the code will be np.delete. Okay, np.delete. You want to delete it from y. Okay, which is the index of the row that you want to delete? Which row? You want to delete the first row? Do you want to delete this particular row? So what that the index of that particular row would be 1. Okay, so specify the index of that particular row, and then you have to specify that, okay, I want to delete this row. This index is of a row itself, not a column. This index is of a row itself, not a column. So I have to write axis is equals to 0. Axis is equals to 0 basically means that you want to delete it row wise. Okay, you want to delete it row wise. You can delete multiple. You can delete so the answer would be 1 2 3 7 8 9. After running this particular line of code, the answer would be 1 2 3 7 8 9. You don't want to delete a particular, like if you don't want to delete just one row but two rows at the same point of time, you want to delete two rows at the same point of time, in that particular case it will be np.delete y, then in list you have to put up, so for example, I want to zeroth row as well as the second row as well, comma axis is equals to 0, and that will delete, that will create another thing for me that will just have 4 5 and 6, because 1 2 3 and 7 8 9 both have been deleted. So we'll just have one particular thing that is remaining, 4 5 and 6 right over here. Okay, are you guys able to understand this? Please let me know. You guys able to understand this? Please let me know, guys. Similarly, if I'm doing the exact same thing, this is our array, 3-dimensional array, 1 2 3 4 5 6 7 8 9. I can delete an entire column as well. Okay, I can delete one or two multiple columns. I can convert this into, I can delete it as 1 3 4 6 7 9. Okay, I can convert it, I can just delete the first row. So for that, it will first column, that will be np.delete. Okay, the y, I want to delete the first column, so I want to delete column, so axis is equals to 1, because I want to delete a column itself. To delete multiple columns, I just want to keep the middle column 2 5 and 8 right over here. I just want the answer to be this, so I just have to write np.delete y comma 0 comma 2 axis is equals to 1. So that will delete the column for me. Okay, that will delete the two columns for me right over there. Okay, so let us go back to our code, and my pen just fall down. Let us look at the code once again. So right over here, we are having our original y. We are having our original y. Now I am writing the code np.delete y comma 0 comma axis 0. So I'm deleting the first, deleting the 0th row. I'm deleting the 0th row. So I'm able to see the answer is now converting from original y to 4 comma 5 comma 6 7 comma 8 comma 9. So this is what happens if I'm deleting the 0th row. Okay, if I'm deleting the 0th row. Okay, the next thing that you want to do is, if I want to delete the column, if I want to delete the first and the last column, for that I'm having axis equals to 1. If I'm doing that on the original y, I'm getting 2 5 8 as our answer. I'm getting 2 5 and 8 as our answer. This is a column itself. Okay, you guys able to understand this? Please let me know. Are you guys able to understand this? Please let me know. Great, guys, amazing, amazing. So now what we want to do is, if we want to add, and now we looked at how to delete an element. Okay, what if we want to add an element to the np array? Okay, what if we want to add an element to the np array? So for that, the first method that we have is the append method. The first method that we have is the append method. Now what do you mean by append in normal English? What do you mean by, so we have already looked at append in lists as well, I guess. We've already looked at append in list as well, where we were able to append a particular element at the end of the list. The same concept goes on for your nd array as well. For example, if you are having, okay, if you are having a one-dimensional nd array, you're having a one-dimensional nd array like this, x is equals to 1 2 3 4 5, and I'm writing np.append append right over here, x comma 6 comma 7 comma 8, then that will just append 6 comma 7 comma 8 at the end. It will just add 6 comma 7 comma 8 at the very end. That is how append works. We have already seen this in lists as well. But what if we want to append in a particular two-dimensional nd array? What will happen then? If you want to append in a two-dimensional nd array, what will happen then? Okay, let's try to understand that. We are having a two-dimensional nd array. Let's see. Here we are having a two-dimensional nd array right over here. Okay, we are having 1 2 3 4 5 6 7 8 9. Okay, we want to append a new row. We want to append a new row at the very end saying 10 11 12. We want to append a new row saying 10 11 and 12 right over here. To do that, we will be writing np.append. Okay, we want to append it to y. This is y. So y comma, what do you want to append? Okay, what do you want to append? So that would be 10 comma 11 comma 12. Okay, because this is a two-dimensional nd array, you have to specify two dimensions itself. Okay, and then you want to specify, you want to append this as a row. So for that, you will be writing axis is equals to 0. That is, you want to append it as a row itself. So now this will create this particular answer for you. Let us see this as a particular example right over here. We are having np.append x comma 6. As you are able to see, we are able to have like one-dimensional array. We are able to append 6. We are able to append 6, 7 and 8 as well. So you can just add like 7, 8. You can append like two elements as well into a one-dimensional array right over here. So we are appending 7 and 8 as well. Okay, that we have already seen that. Okay, the last thing that we want to do is, we are having a y that is a two-dimensional array. We want to append a new row. Right over here. So we are having 1 2 3 4 5 6, that is our y, and we are appending 7 8 9 at the very end. Of this. Okay, so as you're able to see right over here, the axis goes to 0. So we are basically appending a new row. At the very end. Okay, not a lot is left, guys. Only two particular topics are left, then it is over. So please bear with me. So what if I want to add a column? Instead of a row, I wanted to add a new column at the very end. Okay, so right over here, I don't want to add a new row. I want to add a new column. Okay, at the very end. So for example, I want to add 10, 11 and 12 right over here. So for that, we'll be having np.append. Okay, want to append it in y, whatever we have to append right over here, and then axis is equals to 1, because we want to append it as a column itself. Now how to specify this? Now look at it as an individual two-dimensional row, like element itself. How will this look like as a two-dimensional element? 10 11 and 12. How would you make this as a two-dimensional element, guys? So this is your first row, this is your second row, this is your third row. Okay, this is the first row, second row, third row. We'll specify this as 10, second row 11, third row 12, and all that into a two-dimensional array. So if you need to encompass it as well. So this, what you want to add, can be represented in two dimensionals like this. What we want to add, want to represent it into two-dimensional like this. Okay, 10 is our first row, so in an individual element. 11 as a first row into an individual list. 12 as a third row, that is our individual element right over there. Okay, so we'll put it up as this is 10 comma 11 comma 12 right over here. and encompass it, because this is a 2D array. This is a 2D array that we want to add. So now this will add it as an individual column and give us this as an answer. So let us look at that right now, guys. Is able to see we are appending 9 and 10 to that. Okay, we are appending. So this is our 1, 2, 3, 4, 5, 6. To append 9 and 10 right over here. So we are writing 9 as an individual element, 10 as an individual element, encompassing it as a 2D array, and then we are having axis equals to 1. Okay, so let us run this particular line of code. As you're able to see, we are having 1, 2, 3, 9, 4, 5, 6, 10 as our answer. Okay, are you guys able to understand up till here? So now this was how to add it at the very end of the list itself. What if I don't want to append it? I don't want to add it to the very end. I want to add it in between anywhere. I want to add it in between anywhere. Okay, as like I want to add a second column itself, or in between, like I'm having a 0th index column and the first index column. I want to insert it in the middle of it. How to do that? Let's try to understand it. For that, you are having your insert. For that, you are having your insert. Okay, so append will attach it at the very end. Insert, you can attach it anywhere in the middle as well. Let's try to understand that. Let's try to understand this. First, let us look at it as a one-dimensional array itself. So we are having x as 1, 2, 5, 6, 7. Okay, this is what we are having. 1, 2, 5, 6, 7. This is having the index of 0, 1, 2, 3, and 4. Now we want to convert this into 1, 2, 3, 4, 5, 6, 7. We want to convert it into 1, 2, 3, 4, 5, 6, 7. Okay, and the indexes are 0, 1, 2, 3, 4, 5, 6. So where we are adding, where we are inserting this particular 3, 4, at what position are we inserting this 3, 4? We are inserting it at the second index itself. So whatever you want to insert, whatever position that you want it to be inserted, you need to use that number. The code for this will be np.insert. Okay, what do you, in which element that you want to insert? X. Okay, where do you want to insert it? You want to insert it at the index 2. You want to insert it at the index 2. What do you want to insert? So by 3 and 4 right over here. That is what I want to insert at the index 2. That's how the index works. It's the exact same as your append, but you are having an insert index as well, and that index basically refers to the position at which you are inserting your new elements. The position where you are inserting the new elements. Now, understanding this for a 1D element array was very easy. Understanding this from a 1D perspective was very easy. And this is what you want to take it up to the 2D element as well. So we'll now look at the 2D element, guys. Then first look at the code right over here for 1D. You're having np.x equals to np.array 1, 2, 5, 6, 7, the exact like example that we used right over there. Okay, and we are having our np.insert x, 2, 3, 4. Okay, let us look at the answer. I have to run this particular line of code. The original x was 1, 2, 3, 1, 2, 5, 6, 7, and we are able to have, okay, 1, 2, 3, 4, 5, 6, 7 right over here. We are able to have 1, 2, 3, 4, 5, 6, 7 right over here. Okay, that is how we are able to insert 3 and 4 at the index 2. Now, what about two-dimensional arrays, guys? What about two-dimensional arrays? Okay, now for two-dimensional arrays, things get a bit easier when compared to your normal like append itself. Okay, so you are having a two-dimensional array. Let us consider that. 1, 2, 3, 7, 8, 9, 10, 11, 12. Okay, this is our two-dimensional array that we want. We want to convert it into 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. We want to insert a new row at the index 1. Okay, we want to insert a new row at the index 1. So it's very simple to write this code. np.insert Okay, just unlike a back end, like you have to think about like the 2 dimensions and everything. You don't have to do that right over here. np.insert, we want to insert within y. So the name of this particular matrix is y. Where do we want it to be inserted? At index 1. What do we want to be inserted? So just like 4, 5, 6, you can just write it like this. Okay, and you want to insert it along the axis 0. That is along your row itself. As simple as that. Where you want it to be inserted, what you want to be inserted, and which axis do you want to use. Okay, as simple as that. And you are able to do this. Let us look at the code once again, guys. So you're having np.insert, you want to insert a row. So this is y, as you're able to see. This is y right over here, 1, 2, 3, and then 7, 8, 9. So we want to insert 3, 4, 5 inside of it. Okay, 4, 5, 6. Okay, so we are having y, we want to insert the row at the index 1. We want to insert 4, 5, 6 right over there, and the axis as 0. As you're able to see, this was our original y, 1, 2, 3, 7, 8, 9. And now after inserting it at index 1, we are able to get 1, 2, 3, 4, 5, 6, and 7, 8, 9 at the very end. As simple as that, guys. As simple as that. Are you able to understand this? Please let me know. Now, what if I want to insert a column? Hey, what if I want to insert a column? I want to insert a column of all 5s. Okay, I want to insert a column of all 5s. Should I write this again and again? And okay, I want to insert a column of all 5, so it should look something like this. Okay, so 5, comma, 5, comma, 5. I don't want to do that. I don't want to do that. This is a very painstaking stuff. So for that, for example, if I'm having my original array as 1, 2, 3, 4, 5, 6, and I want to convert it into let's say 7, 8, 9. Let's take up 7, 8, 9 as well. I want it to be converted into 1, 4, 7, 5, 5, 5, 2, 3, 5, 6, 8, 9. I want to insert an entire row of 5s. Instead of writing this, there's an easier way of doing that as well. There's an easier way of doing that as well. Let's remove this from right over here. I can just write, okay, as simple as that. I can just write it in just one particular line itself. Okay, so np.insert, okay, in which matrix I want to insert? In y. At what position? So this is 0, this is 1. So at the first position. What I want to insert? I want to insert an entire column of 5s. So instead of writing 5, 5, 5, 5, 5 again and again, I can just write 5 and numpy will all handle that for you. I can just write 5 and numpy will insert all row, a column of all 5s right over here. Same goes for rows as well. Okay, and then where I want to insert it? So axis is equals to 1. That is, I want it to be inserted as a column itself. So I don't have to write 5, 5, 5, 5, 5 again and again. I can just write 5 and it will handle that for you. It will handle that for you. Okay. So let's look at this. You're able to see we are having np.insert y 1, 5. Okay. That is the first index, and 5 I want to insert. And then I'm having axis is equals to 1. That is a column itself. I'm running this particular line of code. As you're able to see, we are getting 1, 5, 2, 3, 7, 5, 8, 9 as our answer right over here. As simple as that, guys. As simple as that. So this is how you are able to cover the entire basics of NumPy. This is how you are able to cover the entire basics of NumPy. I know that my screen is black. Don't worry about it. Okay. This is how you are able to cover the entire basics of NumPy. Are you able to understand this, guys? Pratiksha, axis is used to basically select whether you want to choose like the row or the column. So just like you're having axis, longitude and latitude, similar way you're having the axis like x and y axis. So here 0 basically means row, 1 basically means column. Okay, are you guys able to understand this? Please let me know. So can we delete one row and one column at the same time? Yes, Kush, you can delete that. I will suggest that you look into it on your own. Okay, try to search for it. I know the answer, but try to search for it. You can do that. Okay, it's a bit complicated, but you can do that. Okay, just search for it. You will be able to find it. Okay, are you guys able to understand this? Please let me know, guys. Amazing, guys. Amazing, amazing. So before showing you the attendance for today, guys, I have a request from my behalf. If it's possible, please do like the video, guys. Okay. Please do like the video. It really helps us a lot. Okay, I don't want to tell it again and again, but please do like the video. It really helps us a lot, guys. Okay, so before showing the video, guys, almost 1400 of you are live with us right now. So I'm expecting at least 1300, 1200 likes to be there on the video, guys. Okay, so please take out 1 minute of your time to like the video. Up to that point of time, I am generating the attendance link for today, guys. Okay. Please do like the video, guys. Like I said, it is very important that you are able to like the video. On the basis of that, we are able to generate, okay, we are able to generate like the engagement with the community, and we are able to show different companies that yes, our students are supporting us, they are getting something out of it, and then they are able to, and these companies are then able to provide you guys with the certificates. So please do like the video, guys. It really helps us a lot. It also helps you a lot as well at the end of the day. So please do like the video, guys. So before showing the attendance, guys, please do like the video. Up till now, we have reached almost 900 likes. Let's take it up to 1200 likes, guys. Then I'll show you the attendance link. Okay. Once we have reached 1200 likes, I will show you 1300. Let's take up to 1300 likes. Then I will show you the attendance link, guys. Okay. That's great, Akshay. Thank you so much. Like I said, guys, see, why we are asking you to like the video is we have to show this engagement to the different companies. Okay, that is Google, Microsoft, Amazon, Facebook. And on the basis of that, they basically decide that, okay, people are getting something out of it. That is the reason why they are basically liking the video, coming to live to the video, engaging with the community itself. And that is the reason why we have to like, and then they are able to get us the certificates that we are able to provide you guys. That's the reason why I'm asking you guys to like the video as well. It becomes very easy for us to convince them to give you the certificates. Okay, so please, guys, let's take it up to 1200 likes, and then I will show you the attendance link. Along with that, guys, if you want, you can reach out to us on Instagram as well. Okay, so every single day we try to make sure that we are able to provide you guys with great content on Instagram. So as you're able to see, we are having 5 reasons why it is difficult to get data science jobs. Okay, you are able to get to know a lot of information right over here. Complete JavaScript cheat sheet. Okay, so you are able to learn a lot as well on a daily basis in bits and pieces, and we try to keep things fun and interactive with you guys. So this is one of the memes that our team has created and has posted today. So Chatur, teri MNC में job कैसे लगी? So पहले ये देखो. So that is like we are trying our very best to create, like, take up creative feedback from you guys and try to implement on it as well. So do reach out to us right over there. If you want to connect with me personally, I'm also like DevTown follows just 2 people, Shaurya Sinha and Karan Bajaj sir. So you can reach out to me right over there as well. Okay, you can reach out to me on my personal LinkedIn or on Instagram as well. It's totally up to you. The link to the Instagram page is down in the description of the video. Do reach out to us, guys. Okay, I'll show you the attendance link for today. So this is the attendance QR code for today, guys. I hope that you guys know how to scan a QR code. Please try to do it properly. Okay. We'll keep it up till here, till today's class itself, guys. Thank you so much. It was amazing to see you guys right over here. We'll again meet tomorrow, and from tomorrow we'll be continuing with our Matplotlib and Seaborn, guys. Okay. We'll start with Matplotlib and Seaborn. Okay. How to celebrate Valentine's Day when you're a mechanical engineer? See, my some of my mechanical engineering friends also had girlfriends. So, like, if you are not able to make that, that's your fault. Okay, okay. Sir, do you post reels on Instagram? We used to do that, but we didn't saw a lot of engagement in that, so we have decided to go with posts itself and something that is comic, so that you guys are also able to understand it. Okay. Okay, thank you so much, guys. You can leave right now. The class is over. We'll meet again tomorrow at the same time, and we will try to make sure that we are able to start learning with Matplotlib and Seaborn. We'll also be learning about the roadmap to become the data scientist. That is everything that we'll be learning tomorrow, guys. Okay. Thank you so much, guys. We'll meet tomorrow. Thank you. Thank you so much, guys. Thank you.